Okay, example 2. To the nearest hundredth, now we're in radians. Solve this equation. So again, notice you have some like terms here. We want to solve for x, but these are like terms, these are like terms. If I move things to one side, I would get negative 3 cos x, and move my numbers to the other side equals 2. Divide both sides by negative 3 to get cos by itself. This one is calculator. That is not on your unit circle. So we have to use our calculator, get a reference angle, use our cast rule, and solve. And even though this question says between negative pi over 2 and 3 pi over 2, even though it says that, I like to just solve between 0 and 2 pi first, because that's what I'm used to. So what I'm going to do here is I'm going to find my reference angle. All right, we go to our calculator and do cos inverse of positive 2/3. Now, cos inverse, I make sure my calculator is in radians. We always find a reference angle with positive value. 0.841. And cos is negative in quadrants 2 and quadrants 3. So I'm going to go back to my calculator. I showed you this before. Sometimes when I use a reference angle more than once, I store my answer as x. Because in quadrant 2, it would be pi minus my reference angle. And in quadrant 3, it will be pi plus my reference angle. So by storing it as x, and 3 decimal places, 2.301 and 3.983. I always like to solve between 0 and 2 pi, because then you can just get your reference angle, think about your cast rule, state the answers. But this question didn't ask between 0 and 2 pi, it asked between, and I'll just, right? It asked between negative pi over 2 and 3 pi over 2. Okay? So, between 0 and 2 pi, in green, that would look like this, right? That's 0 and 2 pi, all the way around once. Between negative pi over 2 and 3 pi over 2, I'll show this in purple. What would that look like? Well, that is, I always put 0 in between here. I'll do the positive ones first. It would be 0 to 3 pi over 2, so it's looking here. And then 0 and negative pi over 2, it's looking there. Where were my answers? My answers were an answer in quadrant 2 and an answer in quadrant 3. Can you see that both of these are going to stay the same? All of that work to realize I didn't have to change anything. But if one of the answers was in quadrant 4, I'd have to put an X through that answer and write what would be negative and coterminal with it. So in this case, it worked out that they stayed the same. Nice. They're like, thanks a lot. Why didn't you just ask me between 0 and 2 pi to save me this extra thinking? But at times, you're going to have to cancel out one of your answers and rewrite it. What's really nice about getting your answers between 0 and 2 pi is you've set yourself up nice for the general solution. Because this question also asks us, after solving it there, write the general solution. And the general solution would go x, we do this fancy squiggle bracket. We write our answers between 0 and 2 pi, which we have 2 of them. Did it ask to the nearest 1,000? To the nearest 100, so I'm doing too many decimal places. On the exam, if you do too many decimal places, they actually don't deduct. Too few, you lose an E6 error. But if I rounded this to the nearest hundredth, because now I read the question and I should follow the instructions. There we go. 2.30 and 3.98 plus 2k pi where k is an integer. Very typical calculator question. Can you get your trig function by itself? Can you use your reference angle and your cast rule to find the answers between 0 and 2 pi? Can you take those and switch it to a new domain? Each of these concepts are not hard on their own, but every time we solve a trig question, we have to combine all of those ideas together, which makes it a lot of things to remember. And then in B, they add a reciprocal function. We got root 2 cosecant theta equals, no, cosecant x. They give you an E3 error if the question had x and you decided to write theta. They're like super fussy. Okay, this is what we have. So what do we do when we have a reciprocal function? Because you don't have cosecant inverse or secant inverse or cotangent inverse on your calculator. Well, just like the other ones, step 1, you will get the function, right? Here's my trig function. I'm going to get that by itself by dividing both sides by the square root of 2. Then cosecant is related to which one? Sine or cosine? Sine. So if I know that cosecant of x is this, I know that sine of x, the angle stays the same, but the ratio will flip because they're reciprocal functions of each other. This question's in degrees. Is that on your pie plate? No. We're going to have to find our reference angle. And when you pull out your calculator, on the exam, be prepared to switch back and forth between radians and degrees. So I go to my calculator, I'm going to hit the mode button, I'm going to switch this to degrees. And I'm going to go sine inverse of root 2, square root of 2, divided by -5. Whoops. What did I do wrong? Negative. I've had the negative in there, so I'm going to have to retype it. Take out that negative. Reference angle should always be positive in quadrant 1. So 16.4 degrees is my reference angle. I should write 3 decimals.